Okay, so welcome everybody to the joint OPC and FDT press conference. We're happy to have you with here today. Just a few logistics. I'm Glenn Schultz. I'm the managing director of the FDT Group. And I'll start off by giving you a few background things here, but then we're going to turn it over to our experts, because what we thought we'd do with the majority of our press conference today is, rather than just talking heads and PowerPoint, we'd actually show you how some of the new technology is working. So I brought some experts along that'll do that. And feel free to ask questions throughout this. This is not designed to be a continuing ongoing monologue. So if you have some questions you'd like to ask of our experts as they're talking, feel free to do that. We'll also have time at the end for either group questions, or if you'd like to meet with anybody individually to ask specific questions for your publication, you're welcome to do that. You all received a press kit from us. There's both the USB stick and printed versions of the press information in there, so do please look that over. I would like to call your attention to one of the press releases in here in particular, and that's one of our newest members of the FDT organization. We're actually happy to have a few representatives here from them, is Bartek Corporation. They have joined us to help us in our mobility work in the FDT group, and we're very happy to have them. And if you'd like to talk with them a little bit more after the presentations here this morning, Mr. Zunderman there, if you just raise your hand so they know who you are, is available to answer any questions about it. I think you're aware that the FDT group is heavily engaged in taking the FDT standard mobile, and we're very happy to have a company with the expertise like Bartek to help us in that venture. So with that, let's get into the other topics of the day. So little introductions as to who else we have here in the room. I hope you know these gentlemen, but just in case, Mr. Tom Burke, who is the president and executive director of the OPC Foundation. And we're going to let Tom handle the OPC side of the discussion and presentation this morning. And on the other side, we have Dr. Thomas Hadlik from the University of Magdeburg. And Thomas has been acting as our project manager throughout this joint activity. So both Tom and I hired Thomas to do this work and lead the committee of people that have been active in integrating FDT and OPC UA. So, maybe the question is, why is OPC and FDT collaborating in the first place? What's the activity for? Well, if you look at it on one side, the FDT group really supports all the automation networks. So today, the OPC Foundation has relationships with a number of the standard industrial networks that are out there in their industry, and I was pleased to be part of their joint press conference yesterday where they announced additional collaborations. What's different about FDT in that architecture is we really sit above all those networks, and as you'll see, we talk to every one of those networks. So we're in a very unique place in the automation architecture when somebody says, I'd really like to get information from all those devices that are out there in an installation. The architecture of the FDT is almost ideal for that, because it is already talking to all those devices and peering through any networks that are out there to be able to get access to it. The other nice thing about the FDT standard is we use all configuration methods that are out there in the industry. So, there's some of the legacy devices still use DD or EDDL for configuration. You can use that in FDT. It doesn't render as nice of a graphical image. It's not as nice of a user interface as people want, but it does work inside of FDT. You can also, of course, use our DTMs that you'll be seeing here today, which is probably the most feature-rich way of configuring devices. And eventually, when the FDI device packages hit the marketplace, you'll also be able to use those inside of FDT. So we can really handle all the different configuration methods as well. On the other hand, the OPC standard, supports a very secure and reliable way of exchanging information across the enterprise, and Tom is going to talk about that in a little bit more detail here in a minute. From our perspective, what we really liked as we got into the OPC project, and Dr. Thomas Hadlik will tell us a little bit more about that, is that they have an extensible information model. So the FDT standard has information that it can offer up that other systems may not be able to, such as the hierarchy or the structure of what is in the plant. And so it was necessary to be able to take advantage of this extensibility of the data models to be able to do those kinds of things. And without patting ourselves on the back too much, I think it's pretty well recognized that both OPC UA and FDT are the two most ubiquitous standards in the automation industry. And we're not talking about networks because we're both above the network level in this architecture, but there's no two more widely deployed standards out there. The FDT Group has tens of millions of devices that have been shipped that come with DTMs to support them. Then there's tens of thousands of host applications running as well. Yesterday in the OPC conference, we heard that OPC has like 45,000, I think it was, installations out there of OPC. So these are huge installations and growing on a daily basis. So I think when you have two big organizations like this, two big standards collaborate, it becomes even a better thing. So together, our vision is that we can provide very robust device to cloud level information exchange. We can do it securely, we can do it across the enterprise, and I think everybody's looking at where is Industry 4.0 going, or maybe if you're on the North American side, you look at where IIoT is going, and we kind of get the vision of what's trying to happen there. There's a lot of work to go in those, but I think when you look at the collaboration that you're going to see today, it's clearly a key piece of technology that's needed to be able to move information across the enterprise to enable either one of those solutions. So with that, I'd like to turn it over to Tom to talk a little bit about more specifically about the OPC UA Vision. Tom?
Thank you, Glenn. So it's actually 45 million installations we have. A little bit more than 45,000. It's quite a few more. And, you know, the number just keeps growing. But, you know, really the proliferation of, you know, the smart devices, I don't call it a smartphone anymore. And you know why you don't call it a smartphone? Because all of our children and grandchildren don't use this as a phone. They only use it for browsing the internet. It's all about the industrial Internet of Things. It's about Industry 4.0. It's about connectivity. So today we're going to talk a little bit about the importance of this. And Thomas and I and Glenn, we've known each other way too long, but it's an important thing because the collaboration, and when everybody thinks about Industry 4.0 and the industrial Internet of Things, they want to think about connectivity, but you actually want to think about intelligent connectivity and actually sharing of data and information between the connected devices. It's one thing to say my devices are connected together. It's another thing to say that I can actually really be able to communicate intelligent information between these things. So essentially with OPC UA and our partnership and collaboration with FTT, what we've done is we've taken the best of this whole concept of information, which I call the data modeling part of this, and this is one of the biggest aspects that actually allows all our collaboration partners to take their data from all these different disparate devices and applications and actually be able to move that data into the cloud. You know, we talk about big data, we talk about analytics, but it's really all about connectivity and being able to move this information into a lot of different systems. You know, I don't care if it's SAP or Oracle or Microsoft or, you know, Amazon, they all want access to this device information from the factory floor. So it's about asset management. That's the whole thing with the data modeling. I mean, we are an IEC standard, you know, we've done that deliberately, 62541, and we got communication. But the biggest thing is about the whole collaboration framework of what we're trying to do. So that's just a brief overview of kind of what OPC UA. If you remember anything I say, it's about multi-vendor, multi-platform, secure, reliable interoperability. Notice that word secure that's in the middle of my phrase. That is the biggest thing that's very important to Industry 4.0 and to the, you know, industrial Internet of Things. Not only do you have connectivity, you want to make sure it's secure connectivity. No offense, I don't want you to know everything about my information on my device, right? I want to have you know what the selected information is that's important. I may share more with him, okay? Because he's, you know, he's smiling at me. You're just looking at me. But with that, I'd like to turn it over to Thomas to give a little bit more on the FDT architecture and how we're collaborating together.
Yeah, so the story starts with FDT, and so we want to show you a little bit about what's in the FDT standard, because to really grasp the entire demo, if you haven't seen FDT before, it's important you get just a few of the basic terminologies and concepts down. So we asked Thomas to kind of start with the basics there and work his way up to talk about what specifically now is inside of FDT relative to OPC UA. So Thomas, if you'd like to.
Thank you. So microphone. Okay. So let me start with introducing our small hardware demo that we have here. So on one side we have an Yokogawa hard device which is connected to the PC with a hard modem. So basically this, you could look at this as representing process industry and service use case. On the other side, we have an Weidmuller Modbus TCP device, which is monitoring electric current and a little demo. And it's connected using Ethernet to the system. So basically, you could look at this as the factory automation part of the demo. And for both parts, we have the representation here on a frame application. Each device is represented as with a DTM, and so the hard communication adapter is represented. The Yokogawa device is represented with a generic device DTM, and we have the Modbus communication, and actually this little device is represented by 3 DTMs. So, and it's a hierarchical type of DTM. Okay, so yes, DTM actually, as when it started, it comes up without an user interface, but it's possible that to open up a user interface of a DTM, and then basically the operator is able to see information of the device, nice and graphic information, or an operator may connect to the device. Okay, takes a little while.
And Thomas, who supplies the DTM?
Oh, the DTMs are supplied by the device vendors. So, a device vendor basically supplies a specific DTM for its device, and the DTM knows the device very well. So that's why the DTM is able to display all the information about the device. So. And so I'm using here an Weidmuller DTM to access the Weidmuller device. And as an example, we could observe what's going on the device. Okay, the screen resolution is a little bit high, but actually we are able to see what's happening on the device, and we are able to see the measured current that's going through the device, or the device is measuring the current which is used by the little lamp inside here of the demo. Okay, so there are different, so this is just an example for a frame application. In the market we have very different types of frame application. This one is just a service tool. So typically a service engineer in the field would use such a type of frame to connect to the device. There are other types of frame applications. For instance, they can be integrated in process control system, and then they are able to work with hundreds of devices. So the number of devices that are configured by a frame is not really limited. It's just limited by what's available in the field. So we can connect any number of DTMs, put it inside the frame application, and we are able to support all types of communication. So for instance, here you see hard communication between those DTMs. Modbus communication is supported, and between those DTMs we have a White-Miller proprietary communication. So that's not in public standard. Still, we are able to support that. Okay, and yeah, basically what you just saw was an example of what we call nested communication. So it's possible to tunnel through all the networks. So from one PC, you just use the infrastructure to tunnel through to the actual device that you want to observe. Okay. So with that, I would hand over to Tom.
So one of the things, one of the messages I really want to get across is, and why FDT and OPC UA are coming together, because I'm going to take this tablet later on, and oh, by the way, the first time I've seen this tablet about 10 minutes ago, but I'm going to go use this, and I'm actually going to connect up to what's known as the OPC UA server that understands how to specifically, and Thomas worked on, and it's mapping of all the FDT data deliberately into that server, so it's the only thing that understands how to talk to it. But then I'm going to take a couple generic client applications, and I think we're going to run through one of the maybe the UA expert first, and Thomas is going to drive this. He'll run it over here behind me, so hopefully run it over here, that's fine.
No,
either
it's
way.
Coming up there.
Okay, so this is a very generic client that knows nothing about that device, nothing whatsoever. But what it does do is it knows how to use the UA service architecture and protocol, and he's actually going to be able to connect up to that server. And you've connected up to the server already?
It's already
okay.
connected.
And now what he's going to go do, he's going to select of those devices there. He's going to select one up there. Select the top one, please. And he's going to browse down in here. He's going to hit online next, I believe. And he's actually going to go online to the device. He's actually browsing the data or the metadata inside of the device right now. And we're going to take a look at this.
Because it's really connecting to the device.
You started the server first, right?
Yeah, the server is running in the background, so it's doing the work. Yes. But at this point of time, it's not doing its work. Okay.
Online demonstration.
Let's
trust me.
Finish this one.
This worked a few minutes ago.
Yes.
But the beauty is with the client application knows nothing about the device whatsoever. But what it does is it actually exchanges and it discovers the device via talking to the server, and then can actually discover all the capabilities inside of that deliberately to be able to access that data. So the idea behind this was we were going to be able to show live data changing over there.
So it's connected again.
You're going to drive back down to online?
To online. Okay, here we go.
Observe. Analog input, thank you, and drag it in there. Now that's the particular data item we want to take a look at, and it's going to start monitoring that value.
So it should come up. Okay.
In a perfect world, we would have that data updating and changing like we did before. So I'm going to bring up the other client and
no, okay. I don't understand. And okay. So in a normal way, the data would be moving, right?
So Tom, just to be clear on the architecture, so we've got over on the FDT frame side of things, there's an OPC UA server built into that now, right?
And it actually understands how to talk specifically, to the device and knows everything about it. Yeah, so you're getting an exception base there on the server side. So probably what happened is one of us stepped on the cable when we moved it around. So we've been carrying this around a little too often, but the concept is, and what we'd have is the OPC server who knows how to talk to the device. The generic client discovers all the data or the metadata behind it, should be able to connect up at it. He actually has been able to connect all the way down into it. In terms of the OPC server, we just can't get the connection right now from the OPC server to the physical device to show you that the data is actually changing.
Yes, yeah. It's, you know, let's...
But it does work, trust me.
Yes, yes. No, okay. Let's start from...
Maybe I'll get more lucky on this side, except as the server is what the issue is.
Okay. So the server is coming
We're going to restart the server right now.
It's reading in the data from the DTMs. And there it is. And let's see what happens if we connect again. Okay.
Device
so
top one.
We get the information about the devices.
Online.
And we go online. Okay.
Observe.
Observe.
Analog input. Drag it in there, please. And it looks better this time.
Okay.
There we go.
There. All right.
So he's going to go turn the little dial over, and you'll see data changing. And maybe you can drop the relay output over. Just drag and drop the relay output as well over there into the window. So the concept is it should, you know, show the data right away. We actually do have a system in place that's redundant, that does keep alive, and so essentially there was errors and things going back between the client and server to be able to do that. So, you know, it's just a generic client that knows nothing about the device. Okay, remember that. It knows nothing about this, but you actually can go down and look at this thing, and all of the data and metadata that we put in about the objects is actually in the UA namespace. So what Thomas has done is actually the mapping of all the FDT and the DTM stuff directly into a UA namespace for this connectivity.
So,
all right?
So Tom, I understand this client is in this room, obviously, but we could just as well be halfway around the world talking to the FDT server.
Yeah, it doesn't matter. Matter of fact, what I've got here is a little Android tablet, and I will connect it up. Now, what I've done is I'm connecting up to the OPC server, doing the same thing he just did, and I'll navigate down to that same data point, and then maybe what I'll do is to show that this is actually, that I'm doing this.
I have to. Okay. Yeah. So let's stop this one.
It's coming.
Wait,
So what Tom's going to do, he's got the tablet and he's plugging it into the cable so that you can see it up on the projector, what he's seeing on the tablet. But after he's done, if you'd like, we can pass the tablet around and you could take a look at that yourself.
So this window basically is displays the tablet. So it's I have to click on OK. Now if you use the tablet, you can see what you are doing.
I can't, for whatever reason, it's not displaying on the screen.
It's there.
It's over there. Oh, it's over there, no wonder.
Okay.
It's not connecting up to my line.
Tip it once. So what's the status of the server? So it's
How disconnected
it is
or connected?
connected.
It is connected.
Yeah. That's what it says, right? Want to start from scratch?
Great.
Push it out. Okay. So this is a process client. Okay. There we are.
So the first thing I'm going to do is connect up to the server, which is the one that's talking to this device right here. And then I'll go through and actually browse the data items I'm looking for. And what I'm doing right now is I'm actually adding the items I want to look at and to view these items. So the client basically says, I want to start looking at that data. And what it's doing right now is actually viewing
So you need to
particular
go
objects.
to the monitor.
And then I'll go back. Okay, so I've connected up down to there. Now you'll see that the data over there, those little small numbers underneath that are actually on here, are actually changing as I'm turning this dial over here. So the concept was it's an Android tablet, it's got this client on it, knows nothing about the device itself, but it's able to actually negotiate with the server to understand all of the data and all the things necessary to be able to intelligently show the data value. So that was just kind of a quick introduction to what we're trying to do. And, you know, you could use Microsoft Excel if you wanted to. Microsoft Excel knows nothing about any of this, you know, device-specific stuff. Essentially, it can just be a UA client and do the same thing I just did. You can actually browse down into the device and then be able to intelligently connect up and then view the data in a perfect world. Okay?
Mm-hmm.
Did you have one more client you're going to show?
One
or?
more client. You want to run the other client to show the same?
While they're getting that set up, just a little introduction. What they did was they took a toolkit that's available for OPC UA and wrote a little custom client just to test that concept as well. This might be something that somebody would do if they wanted to create a lightweight mobile application. And you can see it up on the screen there. And what's unique about this is that you can see it has the same topology that Thomas is showing you there as what you can see on the FDT frame. And that's what the purpose of creating this little tool was just to say, okay, since we know what the topology is courtesy of the FDT application, let's show it from an OPC perspective. And so that's what you've got over there now with just an off-the-shelf toolkit to do that.
So he'll do the same thing again, browsing down to the particular data values associated with the device. And remember, we ducked online, and then you go to
So
observe,
and there are the
then
values again.
the data is changing. If you move the dial, you could see that the
with
data
this
is
client,
changing.
the data is not changing. It's a read once client. So
Okay.
it's just displaying the data once. So I would have,
So you've got it only
this is
configured
just
for one kind.
an side project. Actually, for us, the target was to have the same representation of the network structure, like we have it in FTT, so that anybody who knows FTT can get the same look and feel.
Okay, so why is this important? It's all about Industry 4.0. It's all about the Industrial Internet of Things. Now we've showed that we've got the ability to take data, translate that into intelligent information, and make that available through all these different disconnected devices that we can now connect seamlessly through the power of FDT and OPC UA. Okay?
Great. Any questions on that, on the demonstration part of it? Otherwise, we'll wrap up here. Any questions?
Questions also could be asked in German. So if you want to ask in German, I would be able
You can
to
ask in
translate.
German, and then one of my colleagues will translate it in English for me.
Also ich verstehe auch Deutsch. Okay.
Okay? I encourage you to go to the FDT booth and the OPC booth to learn more about what we've been trying to do and why we're trying to do this. I apologize for the little disconnect with our demo. You know, when you do an online demo, we wanted to make it real, we wanted to show it, made a little gotcha, but we got
Sometimes
to
it's
work.
too real.
We got it to work, so maybe that was part of the thing, you know?
Okay, so just to kind of to wrap up what you saw here, you know, we think the combination of FDT and OPC UA make the richest data set that's available out there in the industry. Since we have direct access on the FDT side to all devices on all networks that are in the facility or across the enterprise, connect that with OPC UA, and you've got just a fantastic, rich sort of data. On the other hand, you know, what we did here, we used all off-the-shelf toolkits. So we didn't spend hours and hours and hours writing custom code to show you what you saw here. We took some toolkits and some clients and things that are readily available. In fact, we haven't even paid anybody for these. These are all free demo versions. And we integrated them into the demo that you saw here. And we thought that was important because it really demonstrates the market horsepower of OPC UA, that they've got a rich vendor community with plenty of tools out there, and you don't have to go create your own thing. You could just literally download it from the internet or install an app on an iPad, and you're up and running with it. From an end user perspective, I think you can see how easy it was to take that generic client, browse to a device, find some data that you're looking for from that device, and display it on your client. And up to that point, that client knows nothing about FDT. It was just able to connect to the server, find the information that they're looking for, and boom, you've got it. I think from an end user perspective, that brings huge value to the equation. So next steps is from an FDT perspective, we've got just a little bit of work to do with our joint committee work between OPC and FDT yet. We'll finish that off in the next few months, and then we'll take what you've seen here today and we'll move the FDT server application and its capabilities with the data model behind the scenes. And we've got a copy of the data model specification up here if anybody's interested in just browsing through that. We'll move that technology into our standard FDT toolkit. So on the FDT side of things, when somebody would like to develop an FDT frame application, like you saw Thomas running on his demo over here, they grab our toolkit to do that. So once that all gets integrated into our main toolkit, people that offer FDT frames will immediately be able to offer an OPC UA server as part of that solution. So all those dozens of manufacturers that make FDT frames will have that capability built in, and then you can just grab any of these clients that you saw us use today, or you can write a little custom client like we did for that one application using off-the-shelf toolkits, and you're up and running. And that's all there is to it. It's that simple. So we're pretty excited by the progress that's been made.
Yeah.
I want to thank Tom for...
Think about what you just said. So they're going to take this tool set, and they're going to have all this components in here, and then all of a sudden, all these devices and things, you're going to be Industrial Internet of Things aware. You'll be Industry 4.0 compliant. So we'll have this ability to take all this data and actually push it into Microsoft's Azure Cloud or SAP or Oracle or whatever your other favorite cloud application is.
Yep, and we'll do that before Industry 4.0 is even done.
Before it's even done, we'll be ready.
So, great. Well, I want to thank Thomas and Tom here today for their excellent demonstration. I appreciate that. And are there any questions you'd like to ask before we wrap up here? Please help yourself to snacks. And these guys are going to stick around. If you want to ask any sidebar questions, you're welcome to grab them. And don't forget our friends here from Bartech. Talk to them about the mobile side of things and where FDT is going with that. It's a great conversation. Any questions? Anybody?
It's too early in the morning. They've absorbed it all.
Okay. Well, thanks very much. Thanks for coming here. Enjoy some snacks and enjoy the rest of the show.
Okay, thank you.